Hello everyone, how are you all guys? I think you all are fine in home. So please stay at home, stay safe. So today I am going to discuss an important term in physics known as impulse. So it's very useful in physics and in daily life as well. Okay. So in English point of view, we can define impulse as a sudden desire to do something without thinking about the results. Okay. For that, I will give a simple example, okay, which deals to our daily life. Okay, so you have much interest to read the inspirational book, and one day you are tired from your daily work, and you are decided to read that book, and you did it. You read the book. After reading, you got your inspiration from that book, and you are really inspired. And you are thinking about your future, about your goal, about your ambition. So at that moment, your momentum changed. Your momentum really changed a particular time, at a particular interval of time. So my point is that inspirational book acts as a applied force which acts on you. And it's really useful because it really helps to achieve our goal, at least achieve what you want to do. So impulse is very useful. So we can define, in classical mechanics, we can define impulse as the force into time, force into del t. Okay. So the integral, in classical mechanics, we can define the integral force over a time period known as impulse. Okay, so I can write impulse as capital J is equal to F into del t. So I can write impulse as capital J, which is equal to force into del t, in which F is equal to applied force and del t is equal to time interval. Okay, so exactly impulse is equivalent to change in momentum. That means I can write change in momentum as del p, which is equal to mass into change in velocity, the product of mass to the change in velocity. Okay, so I can write change in momentum as del p, and which is equal to mass multiply into change in velocity. So it is mass into del b. Okay, so we know acceleration a is equal to del b divided by del t. So instead of del p, I can write acceleration into del t. So it is mass into, instead of del v, I can write acceleration a into del t. Okay, so we know mass into acceleration from the Newton's second law of motion. It is force F into del t. So exactly the change in momentum is equal to impulse, which is equal to force into del t. So we proved change in momentum is equal to impulse. And in classical mechanics, we can define impulse as the integral of force over a time interval. Okay, so the SI unit of impulse is equal to Newton into second. As I mentioned, impulse is equal to force into time. So the SI unit is Newton into second, and the dimension is m1 l1 t minus 1. Okay, so this is all about impulse.